Hi, I'm Gary Millette, and this is ELE 110, Electronics for Technicians 1, Fall of 2022. This is topic number 9C, batteries. It's a short little video, so here we go. Batteries have been around for a long time. In the middle of the 1700s, Ben Franklin used the term to refer to Leyden jars, which are actually capacitors that were strung in parallel. By 1800, Volta had invented the first battery. It was a device that produced electricity by the results of a chemical reaction. Actually, if you do a search on the History Channel, you'll find a couple movies they made that talk about early batteries. So today, battery technology is a hot topic due to the desired rapid electrification of the U.S., the desired rapid transformation to electric vehicles, and the demise of the ICE, the internal combustion engine automobile. We have to store things like solar energy and wind energy for use at different times of the day. And battery technology is obviously very important to electric cars, but also is going to be very important to the storage of electricity. So this is a little diagram of a battery cell it's called. And what you see is a liquid, which we call an electrolyte. There's a porous separator and between the negative electrode, which is one material, and the positive electrode, which is another material. And battery current capacity depends upon the physical size of the battery. So what do batteries do? They separate charge due to chemical reactions. So different materials used in the reaction generate different amounts of charge separation and hence produce different voltages. So probably everyone's familiar with these batteries. Typical batteries, a D cell, C cell, AA, and AAA. And these are all Duracells, which do a lot of advertising on TV, so you probably can't miss these guys. They're all constructed from the same materials and have an output voltage of about 1.59 volts when they're unloaded. And that was due to the materials that they're made out of. So there's several configurations you can have for batteries. You can put them in series, put them in parallel. So I show these two possible configurations here. Certainly the series connected batteries, what happens, you connect plus to minus, minus to plus, and so forth. And by doing that, you can actually raise the voltage. Voltages of each battery or cell, are algebraically combined or added. In part B, you see the parallel connected batteries. All the pluses are all wired together, all the minuses wired together. So there's 5 batteries here. What you would get is the same voltage as any single battery, but you would get 5 times the current capacity. So series cells yield a higher voltage while parallel cells yield a smaller voltage but a greater possible amount of current. There are other sources of voltage, obviously. Here I show a solar cell, as long as we're talking about renewable energy. Turns out, this is a diagram of the solar cell. Excuse my cat's tail, but go away, kitty. The sun's energy provides a means to separate the charge. If you want to see more details about this process, you should do a YouTube search, and it'll tell you details of how it works. So here you see the sunlight impinging upon this transparent anti-reflective coating. There's a semiconductor layer. There's 2 semiconductor layers, an N-type and P-type, a junction between the two, a bottom contact, and you take the voltage across the 2 contacts, the top and bottom contact. You don't get much voltage out of a solar cell, but what you do is you take and you put them in series and parallels to get quite a bit of power. Other sources of voltage, this is a generator. And of course, generators have been around for a long time. They work through Faraday's law, generator effect and the motor effect. So mechanical energy is used to separate charge in the generator. What happens is there's a magnetic field, and if you rotate a wire through a magnetic field, the electrons in the wire get pushed. And again, it's called the generator effect of passing a wire or a conductor through a magnetic field. Voltage source symbols, you see 2 of them here, a DC source. The battery consists of several cells. The AC voltage source is a sine wave in the center. These are typical symbols used to represent simple voltage sources. Again, excuse my cat's tail. voltage source in series. So this shows the diagram we showed before. In part A, you can see 3 cells are put in series, and they add up to, since they're 1.5 volts apiece, add up to 4.5 volts. On the right-hand side, and probably people have done this, if you have a flashlight that takes 3 batteries, you want to make sure you put them in the right way, because here you see that the middle battery is opposite polarity of the 2 outer batteries, and it turns out that what we get is the 3 1.5 volt cells, we only get 1.5 volts. They actually cancel out algebraically. Most would say this is intuitively obvious, that you put them like figure A there. The total voltage produced by a series battery arrangement is equal to the algebraic sum of the individual battery voltages. Having to do a little battle with my cat. So here's ways we might take and arrange batteries. In each case here we have a 12 volt 50 ampere hour, and that's how we rate batteries, how many ampere hours they are. So in the far top left we have 4 of them in series, so we get 15 ampere hours at 48 volts. In the middle we put 4 batteries in series, and so we don't get a higher voltage, we get the same voltage at 12, since each one is a 12 volt battery, but we get 200 ampere hours. So we'd have the same power. The top left is 50 ampere hours times 48, whereas the middle one is 200 ampere hours times 12, and we'd get the same algebraic value if we multiply those together. Now on the far right is we can get more power, because here now we take and put 2 series combinations in parallel, and we're getting 100 amp hours at 48 volts. So we would get 48 times 100, which is double what we have on either the 2 left-hand diagrams. Of course, again, it uses 8 batteries as opposed to only 4. In this last slide, typical Prius battery unit. Notice a lot of modules. A battery unit for a Prius is made up of numerous cells or modules, eventually yield several hundreds of volts. Note the wires are coded orange to indicate a dangerous high voltage. So in cars, besides red and black, you now have orange color coding to indicate a high voltage, high DC voltage. And that again is a typical Prius battery unit. Kind of interesting there. This one could be repaired if one of the modules goes or some of the cells go. You might be aware of the fact that a Tesla has about close to 7,000 individual cells that are all hermetically sealed, glued together, and it's non-repairable if I have a Tesla battery that goes bad. That's it for this one.